Hello, we have seen step function in case of continuous and discrete time, then we have seen signum function, and we have completed exponential, that is real time exponential signals in case of continuous and discrete time. So now we are going to take one more important signal, that is your rectangular function. Rectangular function, and it is a very important function, as you also call it as a gate function. So we have discussed this function relating it to a step function earlier, but now we are going to take this function in more detail, rectangular or gate function. So you define a rectangular function. If you are going to plot, by definition first we see what a rectangular function means. So if you are going to see x of t, that is represented as a rectangle of t upon tau. We are just considering the example of a rectangle of t upon tau for the first time, then we will be taking operations on this rectangular function. So a rectangle of t upon tau, in this expression, this tau represents the total width of the rectangle. It represents the total width. It is important because the next function that we are going to take will be the triangular function, where the similar representation you will be having, but in that case this tau represents the width of any one side. So now a rectangle of t upon tau is a rectangle that is centered at origin. So if it is centered at origin, then you have to plot a function that is having same width on both sides, and this total width is going to be tau. This total width is going to be tau, and if this total width is tau and it is centered at origin, it means the width on either side is going to be tau by 2. So these points are minus tau by 2 and tau by 2, and during this interval this represents the amplitude. This represents the amplitude. So you can say that a function a rectangle of t upon tau represents a rectangle having value a, but only in the duration, that is from minus tau by 2 to plus tau by 2. So if you want to define mathematically, then you can represent a rectangle of t upon tau can be written to be a for minus tau by 2 to plus tau by 2. If you see here, we are having two discontinuities, that at t is equals to minus tau by 2, at t is equals to plus tau by 2, we can see that the function is discontinuous, that at this point if you see the shape, then it is the shape of the function, that this function is having 0 value, then suddenly it increases its value to a, then it is having constant at a, it is going to be constant, then again it is going to suddenly change its value from a to 0. So now if you want to define the values at the points of discontinuity, then again you can approximate the values to be this value a plus after this discontinuity the value is 0. So a plus 0 by 2, that will be a. Similarly at t is equals to minus tau by 2 also, this value is 0 just before minus tau by 2, and just after minus tau by 2 the value is going to be a. So again the average is a plus 0 by 2, that is a by 2. So you can write a rectangle of t by t is going to be a in the duration minus tau by 2 to tau by 2. The value can be approximated to a by 2 for t exactly equals to plus or minus tau by 2, and it is 0 elsewhere. You can say that it is going to have values constant at a if the time is in between minus tau by 2 to plus tau by 2, and it can be approximated to a by 2 at t equals to plus or minus tau by 2, and it will be 0 outside this interval, that is for either t greater than tau by 2 or t less than minus tau by 2. So this definition can also be written as this a rectangle of t upon tau. If you want, then you can represent this as it is going to be a for mod of t less than tau by 2, it is equals to a by 2 if mod of t is exactly equals to tau by 2, and it will be 0 if mod of t is greater than tau by 2. So it can be one of the definition that you will be using, and you can see that why we can take this value. If you plot the graph of, either you can take the graph or using the definition, as you have said that mod of t means mod of t is going to be plus t for t greater than 0, and it will be minus t for t less than 0. So if you have written mod of tau by 2, it is minus mod of t is going to be less than tau by 2. If you say this limit mod of t, if you say, then it is going to be less than tau by 2, that you have written. So by this definition, there will be two conclusions. That means if you are taking t to be positive, then this mod of t will be represented as plus t. For t greater than 0, first case we are taking two cases. First for t greater than 0 and for t less than 0. We are taking two cases. If t is greater than 0, then mod of t can be written to be plus t. So this plus t should be less than tau by 2. And if t is negative, that is t less than 0, then this mod of tau will be minus t. Then this minus t must be less than tau by 2. So if minus t must be less than tau by 2, then you can say that this t can be greater than, if you are shifting these values, you are shifting t to other side, so it will be plus t and the sign will be greater than, and this tau by 2 will come to this side with a sign negative, so t must be greater than minus tau by 2. So from this you have obtained t must be less than tau by 2 and t must be greater than minus tau by 2. So if you are saying that function is going to be a for mod of t less than tau by 2, then you can define this that mod of t less than tau by 2, it is nothing but for t in between minus tau by 2 and plus tau by 2. You are getting this from here. It is mod of t less than tau by 2, it means that t must be greater than minus tau by 2. So you have written t must be greater than minus tau by 2, and from this relation you have taken t must be less than tau by 2. So this definition can be converted into this, that mod of t must be less than tau by 2, then only the value of this rectangular function is going to be a. It will be a by 2 at mod of t exactly equals to tau by 2, and it will be 0 if mod of t is going to be greater than tau by 2. So we have what we have considered now, it is a particular rectangle that is centered at origin. If the rectangle is not centered at origin, then in general, the general representation you can write, general representation of rectangular function. The general representation is going to be x of t is equals to a rectangle of t minus center upon tau. All the meanings are same, that is this a will represents amplitude in the duration of existence. This tau is going to give you the total width, it is going to be the total width, and this center will define that where this rectangle is centered. If you are going to say you are going to take x of t that is equals to 4 rectangle of t minus 5 by 3. So what will be the shape, how we will be plotting this signal? This rectangle you can see that it will be having value 4 in, and the total width is going to be 3. Now this function is centered at, you have to compare this relation with the standard representation, that is t minus center. So it will be having the center at t is equals to 5. If it is minus sign, then if here also you have given minus, then the center will be lying at plus 5. If say we are taking that x of t is 4 rectangle of t plus 5 by 3, then if you compare this expression with the standard representation, then you are going to find out the value of center to be minus 5. It means this function will be centered at minus 5. So you have plotted a rectangle, you are going to plot a rectangle that will be centered at minus 5, and the total width of this rectangle is going to be 3. It means if this is center of rectangle, then you will have to take 1.5 width towards its right side and 1.5 width towards its left side. It means you are now going to draw a rectangle which will be existing from minus 6.5 to minus 3.5, and in this duration the value of this rectangle is going to be 4. So it is 4. So you have plotted the signal, that is x of t that is equals to 4 rectangle of t plus 5 by 3 with respect to t. It is your function x of t. So now we will be using 3 methods to represent any rectangular signal, but to move to that section, before moving to that section, if we have defined this function to be a rectangular function, a rectangle of t upon tau, it is the standard rectangular function having total width tau and amplitude a in duration in that duration. So now if we define, as we have taken a step function that can have any amplitude value, that is if you say 10 ut, then still it is a step function, but it will be having amplitude 10. So if we have defined a unit step function, in that case you have defined the amplitude to be 1. Now similarly if we define a rectangular function if we name a rectangular function to be a unit rectangular function, then this unit word defines the area. It means if you are going to plot, if you are now taking unit rectangular function, so the function, it will be a rectangular function, it will be a rectangular function with total area is equals to 1. Total area equals to 1. So now, if you see the value of area of this rectangle, if you are going to take this standard rectangular function, then it is a rectangle, so it will be having the area width into height. So the area, if you see here, the area value of this rectangle, area is what? Width, that is total width is tau and amplitude is a. So the area of this function is going to be a tau. Rectangle function will have an area a tau. And you know that there is no effect of shifting or time reversal. So shifting or time reversal is not going to change the area of this rectangular function. To change area of rectangular function, what you must have to change is either you can change a or you will be changing your duration of existence, that is tau. So if you are going to define a rectangular function having area 1, then if you say that you are going to draw a function, let it is a function which is having this total width 1, that is from, it is existing from minus 0.5 to 0.5. This total width which is going to be your tau, if you put this tau value to be 1 and if you are taking this amplitude again to be 1, so it is your unit rectangular function which is normally expressed by this representation pi of t, but it is not necessary. So you do not have to remember this representation. Whenever it will be given to you, then by name it will be a unit rectangular function, or simply it will be plotted like this. Again, if you can see the area, as you have defined, area is going to be a tau. So if a is 1 and tau is 1, then area is going to be 1. So it is a unit rectangular function which is centered at t equals to 0, that is which is centered at origin, having a total width of 1. Therefore, as it is symmetrical about the origin, so the width on either side is going to be 0.5, that is tau by 2, and the amplitude value is 1. So it is your unit rectangular function. Now if you see either unit rectangular function or standard rectangular function, then you have drawn a rectangular function like this. If you have written here a rectangle of t by tau, if you have substituted values of a and tau to be 1, so what this pi of t represents? It represents a rectangle of t. We have substituted values of a and tau to be 1, so the representation changed to only rectangle of t. You have put a1 tau 1. So now if you have seen the function a rectangle of t upon tau with respect to t, which is existing from minus tau by 2 to plus tau by 2 with value 1. So now in this case also, or in this case, you can see that as this function is going to exist symmetrically on both the sides. So if you are going to take the time reversal on this function, say it is your function x of t, if you are going to find x of minus t for this function, that is if you will be folding this function, then again you will be having the same function. It means it is an even function. So you can say that rectangular function is an even function. And if you know that if a function is even, then x of minus t is going to be x of t. If a function is even, then x of minus t is x of t. So if you take a rectangle of either t upon tau, and if you replace in this representation, if you have taken instead of t, you have taken minus t, then it is going to be same as that of a rectangle of t. There will be no effect of time reversal, and you can just discard the sign of time reversal. So a rectangle of minus t upon tau will be same as that of this. Similarly, if you replace t value by any other value, that is if you are going to find a rectangle of minus of t plus or minus t naught upon tau, we have replaced this t by t plus or minus t naught, then it is going to be same as that of a rectangle of t plus or minus t naught upon tau. You just can discard this negative sign. If it is written to be a rectangle of b minus at, if it is written to be like this, then what you can do is you can take a rectangle of, if you can take this minus sign away, then outside, then you can take minus a, if you take in common, then it will be t minus of b upon a. And now you can discard this negative sign. So this function will be equivalent to a rectangle of a into t minus b by a. You are just taking the sign of time reversal common outside and you can discard that sign. The function will have no effect of time reversal. So, a rectangle of b minus at can be, it can also be written as a rectangle of at minus b. You just have, if you have just taken the minus sign common, then it can be written to be like a rectangle of at minus b. So, this rectangular function is an even function. Again, if you replace this t by t plus or minus t naught, then you will have to replace that this t also by t plus or minus t naught. Signal, that is, you have to plot signal x of t, that is rectangle of 3t, that we have to take 2 rectangle of 3t. Then just by comparing it with a rectangle of t upon tau, it must be in the form of t upon tau, then we can represent. We will be seeing different methods to represent a rectangular function, but if in this case, if you see here, we can write it like x of t can also be written as 2 rectangle of t upon 1 by 3. Now, if you represented this signal like this, then now you can compare it with your standard signal, that is a rectangle of t upon tau, and the value of tau is going to be 1 by 3. If you compare it with 2 rectangle of t minus center upon tau, which is the actual representation, then you came to know that the signal is centered to be at origin and the total width is going to be 1 by 3. That means width on either side of the origin is going to be half of this, that is 1 by 6. So, you can just plot this signal and you can represent this signal from minus 1 by 6 to plus 1 by 6. So, the total width is going to be equals to this tau value. It is your tau and it is your a. So, the value of the signal is going to be 2 in the duration from minus 1 by 6 to plus 1 by 6. So, there are different methods using which you can actually plot a rectangular function. Say if you are having a rectangular function, that is going to be, if you have to plot x of t, that is 4 rectangle of minus t plus 4 divided by 2, if you have to plot this signal. So, what methods can be opted? If you take first method, then in the first method, what you know now, that a unit rectangular function is defined as, it is your unit rectangular function which is existing from minus 0.5 to plus 0.5 with respect to t having value 1. It is your unit rectangular function that is said to be rectangle of t. So, if you have the knowledge of this function rectangle of t, so by performing operations on the rectangle of t, you can obtain this function. And first what you have to do here, you just have seen that rectangular function is an even function. So, whenever there will be a time reversal in rectangular function, then your first step must be, you must have rectified this time reversal function. That means you must have to eliminate this time reversal, and so you can write 4 rectangle of, if you have taken this minus sign common, then it will give you t minus 4 divided by 2. Therefore, it can be simply written as t minus 4 divided by 2. So, now you can see that this rectangular function you have to plot, it can be plotted using operations on unit rectangular function, that is rectangle of t. So, if you can generalize it, if you can write it here like 4 rectangle of, if you want, then you can write t by 2 minus 2. It can be written like this. Now, if you see, you have to perform operations. If you want to move from right to left, then you just have to take time shifting first, that is you have to delay the unit rectangular function by 2 units. Then you have to take scaling by 1 by 2. It means you have to divide existing limits of the function after that you obtained after shifting operation. You must have to scale that function, that is you must have to divide the existing limits of that function by scaling factor, which is 1 by 2 in this case, and after that you will have to take amplitude scaling by 4. So, it is your unit rectangular function. First, if you delay this function by 2 units for the first time shifting operation, then you can plot this function. Suppose we have taken this function rectangle of t minus 2. We just have performed shifting operation on this function. So, how this function will be now looking like? If you want to plot this function, that is rectangle of t minus 2, then you are going to shift this function toward right hand side by 2 units. So, this 0.5 point will be at 1.5 and this 0.5 will be at 2. So, with respect to 2, you have performed first time shifting operation on unit rectangular function and you have obtained this function. Now, you have to scale this function by scaling factor 1 by 2, alpha is 1 by 2. So, when you will be dividing this limit by 1 by 2, it is what? It will be 2.5, actually you are shifted this function by 2, so it will be 2.5. So these limits are actually it is 3 by 2 and it is 5 by 2, and you are now going to divide these limits by scaling factor alpha, that is 1 by 2. So 3 by 2 divided by 1 by 2 will give you 3, and 5 by 2 divided by 1 by 2 will give you 5. So we can now plot the signal that is going to be existing in between 3 to 5 for time t with value 1. Here the value is 1, as the value of rectangular function, unit rectangular function is 1. So you just have shifted this function, so the value is 1. Again you just have time scaled this function, so the amplitude is again 1 here. It is your function what? Rectangle of t by 2 minus 2. Now you must have to apply a amplitude scaling by 4, so you just have to multiply the amplitude by 4. So now you will be getting, if you want to find 4 rectangle of t by 2 minus 2, then this amplitude will be 4. So you have obtained this function, that is 4 rectangle of t minus 4 by 2. So whenever there is a time reversal, then first thing that you have to do is take this minus sign common and discard it. So you will be having the function like this. So we have obtained the first this result using first method. Say it is the first method that if you directly perform operations on the rectangular function, then you can get any rectangular function that is given to you. Method 2 can be taken as method 2. As you can define this unit rectangular function to be, if you write rectangle of t, then it can be written as, it is having value 1 for mod of t less than tau by 2, that is 0.5. It will be having value 0.5 for mod of t exactly equals to 0.5, and it will be having value 0 for mod of t greater than 0.5. Then if you want, then you can find out this signal directly just by replacing. If you want to find out now the value of rectangle of what you have to obtain? You have to obtain rectangle of minus t plus 4 by 2, for which you have solved, and you have obtained it like t minus 4 by 2. So if you want to find rectangle of t minus 4 by 2, then you just have to replace all t values by t minus 4 by 2. So it will be rectangle of t will be 1 for t minus 4 by 2. Mod of this value must be less than 0.5. It will be 0.5 if this t minus 4 by 2 equals to 0.5, and it will be 0 if mod of t minus 4 by 2 is going to be greater than 0.5. So you just have to simplify these to find the limits of t, because you just have to plot this function with respect to t. So you want to find the value of t or mod of t. So how you represent the mod function? If you have to take mod of t minus 4 by 2 less than 0.5, then by this value, if you see here, there are two possibilities. If you say the function in between this mod part, that is, if this function t minus 4 by 2, if it is greater than 0, the first possibility, and if this function t minus 4 by 2, if it is less than 0, the second possibility. So if this function is positive, then you know that as mod of t is equals to plus t for t greater than 0, similarly mod of t minus 4 by 2, for this value to be greater than 0, it will be plus of this value only. This means you will have to write for this value greater than 0, you will be writing t minus 4 by 2 less than 0.5, and if this value is negative, then mod of this value will be minus of this. It means now you will have to write minus of t minus 4 by 2 must be less than 0.5. We have just distributed, you can say we have splitted this mod of t minus 4 by 2 in two cases. When let us say it is x, then mod of x is plus x for x greater than 0. So if we have taken x greater than 0, then we have equated this mod of x to be plus x. So it is plus x less than minus 0.5, and if this x is less than 0, if we have considered this case, then mod of x is minus x. So we have written minus of this value must be less than 0.5. If you solve this, then you are going to get t minus 4 less than 1, or you can write t less than 5. If you just shift minus 4 towards other side, then you will be having the value of t must be less than 5. Similarly, if you solve this, then you can write minus of, if you multiply this, then you can write minus t and minus minus plus 4 must be less than 1 minus t plus 4 must be less than 1, then you will have to shift this minus t to other side. So, t will be greater than, and this one will be shifted towards other side. So, you are having t must be greater than 4 minus 1, that is 3. So, the limits that you have obtained by this t minus 4 by 2 must be less than 0.5 is t must be either less than one thing, that t must be less than 5 and t must be greater than 3. So, in between these two intervals, the value of signal is going to be plus 1, as we have plotted here. You can see here we have just plotted in between 3 and 5 the value of this signal. If only rectangle of t minus 4 by 2 is considered, then the value will be plus 1, and if you multiply this value with 4, then what will be the value? This one will also get multiplied by 4 due to amplitude scaling, and you will be having the same signal that you have obtained earlier. So, two methods we have seen, that either you can perform operations on unit rectangular function, or using the definition of unit rectangular function you can make the replacements, but these methods can confuse a lot if you are going in the exam and if you are in hurry, then it may produce some errors. So, you just do not have to use both of these two methods. What you have to use is, you just have to use the standard representation of rectangular function. Recall this example, and if you are saying that it is the basic representation or standard representation of a standard rectangular function. So, by just comparing with it, you have to plot now x of t function that is given to you as, it is 4 rectangle of minus t plus 4 by 2 it was, and we have just removed the minus sign and we have obtained this signal to be t minus 4 by 2. So, if you simply represent this signal, compare this signal with a given representation, then it is a rectangle of t minus center upon tau. It means this 4 is going to be the center where this rectangle is going to be centered, and this 2 is the total width tau. It is what? Total width tau. So, you just have to plot a rectangle, which is centered at 4. It is a rectangle which is centered at 4, total width is 2. So, the width on left and right half of this point 4 will be 1 and 1. So, you are having a signal which is existing from 3 to 5, total width tau is 2, it is your total width tau, that is 2, it is your 4 which is your center, and amplitude of this signal is going to be 4. Just by comparing this representation, it is 4, so it is your signal 4 rectangle of t minus 4 by 2. It is the same again that we have obtained in the previous two methods, but you can see that to find the rectangular function using this standard representation comparison, we just do not have to apply any operation, or we just do not have to calculate more. So, it can be followed and it can be used for different purposes to plot rectangular function. Now, if you take one more example, say you have to plot x of t, that is 2 rectangle of 3t minus 5. If you have to plot 2 rectangle of 3t minus 5. So, now again you just have to compare it with your standard representation, which is going to be a rectangle of t minus center upon tau. It means you just do not have anything to be multiplied in this t. Here, as t is having a scaling, so you just have to take this scaling factor common, and you can write it like 2 rectangle of, if you take this 3 common, then it is t minus 5 by 3. Now, again for comparison, you can write this tree to be, that is 2 rectangle of, you can write this again as t minus 5 by 3 divided by 1 by 3. You can write like this. So, now you can compare a rectangle of t minus center upon tau. So, it is going to be your center where the rectangle is going to be centered. This point is minus, if t minus point, if sign is minus, so center will be lying at plus 5 by 3. If this point will be positive, then the center will be at minus 5 by 3, and it is going to be the total width tau. This 1 by 3 is total width tau. So, we just have to plot a rectangle which is centered at 5 by 3. So, we just have plotted one rectangle, let the center is 5 by 3. So, if the total width is 1 by 3, it means width on either side will be half of this. It means this point will be 5 by 3 plus half of this, that is half of 1 by 3, that is 5 by 6, 5 by 3 plus 1 by 6, and this width, this point will be 5 by 3 minus 1 by 6. If this width is 1 by 6 and this width is 1 by 6, it is origin centered at 5 by 3. So you are just taking this point to be 1 by 6 more than 5 by 3 and 1 by 6 less than 5 by 3. So you can obtain these 2 points, and the amplitude here is simply going to be the value which is written before this rectangle, that is 2. So it is having amplitude 2. It is your function 2 rectangle of 3t minus 5. So you just have to represent, you just have to write down the given expression for x of t in the form where you can compare it with this standard representation, that is a rectangle of t minus center upon tau. So now we are going to take some more examples on this rectangular function. Then till now we have used this equation, that standard representation, to plot the function. Now the same expression will be used to identify the expression for a rectangle that is given to you in a graph. So you can represent that any rectangular function in plot using this expression, that is a rectangle of t minus center upon tau. So we have seen the standard representation of a rectangular function that is given as x of t is a rectangle of t minus center upon tau. So we have represented two functions, that if the rectangle is centered at origin, then the representation is going to be a rectangle of t upon tau, and you have represented this signal in between minus tau by 2 and plus tau by 2 with respect to t having amplitude a. And if you have substituted the values of a and tau to be 1, then you have obtained the function, that is unit rectangular function. You have represented it rectangle of t existing in between minus 0.5 and plus 0.5 with amplitude 1. So we have seen this. Now we are going to use this representation to identify the representation for given plot. And before this, we can have practice on one more signal for representation, to see the representation of rectangular function. If we have to add, say we have signal x of t, which is addition of two rectangular function. Say we are going to take two functions as 4 rectangle of, let us say, minus 2t plus 8 divided by 4, or we can take minus 2t plus 4 divided by 8, and plus another signal is 2 rectangle of 4t minus 16 upon 16. If you have to add up these two rectangular functions. So first you must have to represent both rectangles. Say it is your first function x1 of t, let it is your first function x1 of t, and it is x2 of t. So x of t is going to be the sum of these two signals x1t and x2t. Now as you can see here, again this rectangular function is having time reversal, so you just can take common this negative value and discard it. So if you take this common, so x1 of t, you can write this as, if you write like this, 4 rectangle of, if you have taken minus 2 common, then it can be written as t minus 2 upon 8. Similarly, you can write x2 of t to be 2 rectangle of 4 common. If you have taken, then you can write it like t minus 4 divided by 16. So now you are going to get the exact values of rectangle functions, that are x1 of t is equals to this 4 rectangle of, you can directly discard this negative sign, and this 2 will get cancelled with this 8. So it is, this minus sign is discarded. So the function is simply t minus 2 by 4. It is your x1 of t, and x2 of t is equals to this 2, again it will be 4. So it will be 2 rectangle of t minus 4 by 4. So you have to plot two rectangles, and to plot these two functions you just have to compare the representation with standard representation. So in the first case, it is going to be the amplitude, that is a, it is your total width tau, and this is your center. If you are comparing with t minus center, it means centered, this rectangle is centered at plus 2, similarly this rectangle is centered at plus 4, having the value of total width tau equals to 4, and it is the amplitude value for this x2 of t. So just representing these two functions, first we can represent signal x1 of t. It is x1 of t, that is 4 rectangle of t minus 2 divided by 4. So this rectangle is centered at plus 2, having total width plus 4. So we have plotted a rectangle, it is having total width 4. It means if you are going to center a rectangle at t is equals to 2, then it will be having width 2 in left hand side of this point and 2 width in the right hand side of this point. So this rectangle will be existing in between 0 and 4 seconds. So it is the value of t is equals to 4 seconds, it is t is equals to 0, and the amplitude is going to be 4. So we have just centered, we have taken a rectangle which is centered at 2 and having total width equals to 4. So it is your function x1 of t. Similarly, if you plot just below it x2 of t, again x2 of t is the rectangle which is 2 rectangle of t minus 4 by 4. It means you have to take a rectangle which is centered now at 4. Let this value, it is 4. So now the rectangle is centered at this point, and as the total width is 4, so you are going to take width 2 on each side of this point. So this rectangle will be in between 2 and 6. As this point is 4, so this point will be 2 and this point will be 6. So now this rectangle is having an amplitude that is equals to 2. So if you have to add up these two rectangles, then you just follow the concept that you have learned. You are going to just add up these two values. So x of t will be in between 0 seconds and 2 seconds. If it is the point of 2 seconds, then in between 0 and 2 seconds only this function is existing with a value 4. So the value between 0 and 2 seconds is going to be at 4. Now in between 2 and 4 seconds both functions are existing simultaneously. So the net value will be 4 plus 2, that is going to be 6. So in between this 2 second and 4 second, the value will be 4 plus 2, that is 6. After t is equals to 4 seconds, this function still exists but it has 0 value. So 0 plus 2, the net value after t is equals to 4 seconds is going to be the value of this rectangle, that is 2. So it is your plot which is having values 2 in between, these points are 2, 4 and 6. These points are 2, 4 and 6 with respect to t. So you have just plotted the signal x of t, that is sum of two rectangles. If you have to multiply these two signals, if you have to find out the product, if I am just plotting the product here with respect to t, if you have to plot x1 t into x2 of t, first we have plotted addition of these two signals, then for this region 0 to 2 seconds the value of this rectangle is 4, then in this region 2 plus 4 we have added the values and the values are 6, and during this interval this only rectangle is existing, therefore the value is 2. Now if we have to multiply, then the result of multiplication will be existing only in the duration where both the functions are present simultaneously. So in between only 2 and 4, this is the only interval in which both of the functions are having non-zero values. So you just have to multiply these two values. It means 4 into 2, the value will be 8, but will be existing only during this interval, that is from t is equals to 2 seconds to 4 seconds. So the product is going to exist in between 2 seconds and 4 seconds, and the value is going to be 4 into 2, that is equals to 8. So this is how you multiply two rectangles or add two rectangles, but for either multiplying or adding, you just have to represent these two rectangles first, and for representing rectangular functions, you just have to follow this standard representation, and with which you can easily plot any rectangle. So now as we have seen that rectangle can be formed using combination of step functions. So if we are taking a rectangle, you can see this, the relation between rectangular and step function. If we are going to discuss the relation between rectangular function and step function, then you have represented a rectangular function which you have, if it is existing from minus tau by 2 to plus tau by 2 with value a, then you have written it as a rectangle of t upon tau. So if you want to represent this function, this gate function which is existing in between minus tau by 2 and plus tau by 2, then from the concept of step function that we have learned, we can represent this function, that is a rectangle of t upon tau. It is difference of two step functions. We know that the first step, that is starting, or you can directly write this expression of this function in terms of a step function taking arrow marks. So you just have to write the expressions at the point of arrow. So at this point the expression will be amplitude a, and step has started from minus tau by 2. So the expression will be a times t plus tau by 2, and again you have to subtract one more step from it, which is going to start from plus tau by 2. So you have written the expression to be a u of t minus tau by 2. It is nothing but you have represented this function, if the amplitude were a, then you have represented it u of t minus a minus of u of t minus b. So here a is minus tau by 2, so this sign is plus tau by 2, and b is plus tau by 2, so you have written t minus b, that is t minus tau by 2. So it is the representation between a rectangular function and a step function. Now you have also seen that we can represent any step function in terms of signum function, and we have represented that u of t plus or minus t naught can be simply obtained by taking signum of this value, whatever it is, t plus or minus t naught plus 1 divided by 2. So if we can express a rectangular function in terms of step function, then we must represent it in terms of a signum function as well. So we are just going to substitute the values of these step function in terms of signum function. So you will be having a rectangle of t upon tau is equals to, a can be taken outside common from these two values. So we can write a times this u of t plus tau by 2 can be written as signum of t plus tau by 2 plus 1 divided by 2, and minus we have taken a outside common, so it can be written as signum of t minus tau by 2 plus 1 divided by 2. Now again, as the signal is existing in the finite duration, so you can see that the total constant term will cancel out, as here it is plus 1 by 2 and it is minus 1 by 2. So the net constant value will be 0, and you will be obtaining the representation a rectangle of t upon tau in terms of signum function as a by 2 times signum of t plus tau by 2 minus of signum of t minus tau by 2. So it is the representation of rectangular function in terms of signum function. You can represent any given function that is rectangular in shape in terms of either step or signum function. So now if we have to express any given signal in terms of rectangular function, then you will see that there are two possible representation which both can be correct. Having a signal x of t which is given to you as, say it is a function that is given to you as this. Let these points are given to be, let it is 4, this point is 6 and it is 8 with respect to t, and these amplitude values say it is 4, it is 10 and let it is 15. So if you have to represent this signal in terms of rectangular functions, then you can have two possible representation for this. For first representation, if you consider the rectangles to be horizontal, that is if you take these horizontal rectangles, if you say that it is your first function, that is first rectangular function x1 of t, it is your second rectangular function x2 of t, and it is your third rectangular function x3 of t, then if you take such rectangles, then also you can represent the signal x of t. And one more representation that you can take for the similar given question, same question, that is x of t, if you are going to take this signal which is given to you like this, these points are 4, 6 and 8 and these amplitudes are given to you as 4, 10 and 15. So now if you want to take vertical rectangles, again you can represent, if you take this function, this rectangle to be x1 of t, this rectangle to be x2 of t and this rectangle to be the third function, that is x3 of t. So in both the cases you can say that we can represent this signal x of t here as x of t is equals to x1 of t plus x2 of t plus x3 of t. And in this case also, if you have considered these to be x1 t, x2 t and x3 t, then you can again represent this signal x of t to be the sum of these three signals x1 of t plus x2 of t plus x3 of t. See, these are easy things you can represent, but in the further chapters when we will be discussing energy, then which you can say that which representation you should take to minimize the complexity of the problem. Then you can see here in this case, if we are going to define x1 t, x2 t and x3 t like this, then these functions are overlapping functions. If you take this duration, then in the duration from 4 to 8 seconds, these two signals are occurring simultaneously, means these two signals are overlapping. Similarly, this x3 of t is again overlapping with both of these two functions in the interval from 6 to 8. So whenever there is overlapping functions, then you will see that energy calculation will be dependent on the common area between the functions, so it will be more hectic. So what you have to do, if in further lectures if you have to express any function in terms of rectangular function, then you are going to take non-overlapping functions like this. If you have taken this x1 of t, this to be x2 t and this to be x3 of t, then you can see that when x1 of t is ending, then only the x2 of t function is starting, and this x3 of t is starting after when x2 of t has terminated at 6. So these functions x1, x2 and x3, in this case x1t, x2t and x3t are non-overlapping. These are non-overlapping functions, and we can say give preference to this representation that we are going to take the functions x1, x2 and x3 as non-overlapping functions, but in this case we can take these functions also. So if we want to take first the column stepwise representation of horizontal rectangles, so what you can see in these rectangles, this one x1 of t is a rectangle which is existing in between 0 and 8 seconds. It means the total width that is represented to be tau, the tau value for this x1 of t is equals to 8, and the height of the rectangle, that is amplitude of the rectangle, is going to be 4. In the second rectangle, it is existing in between 4 and 8 seconds. It means it has total width of 4 seconds, and amplitude is not going to be 0 to 10. The amplitude is going to be the difference of these two amplitudes. That is, you can suppose that these functions are superimposed on one another to find out the total function x of t. So in case of x2 of t, the width of x2 of t is 4 seconds, but the height or amplitude of this rectangle is going to be 10 minus 4, that is 6. Similarly, for this x3 of t, width will be 2 seconds and the height is going to be the difference of these two values, that is 15 minus 10, that is equals to 5. So three things that you have seen here, that we can take signal, because we know that we are going to use the standard representation. That is going to be what? We are going to write the expression as, for any rectangular function, we are going to write x of t is equals to a rectangle of t minus center upon tau. So what three things we need to find out to give the representation to any rectangular function? We just have to find out a, tau and center. We have seen that value of a and tau can be represented. Now to find out the center, you know that rectangle, wherever it is centered, it is having equal width on both the sides of that point. Therefore this center can be obtained as a midpoint of the total width. That is, if we are taking a rectangle which is existing from A to B, if it is existing from A to B, then the center will be at midpoint of this, that can be taken as an average of the points. That is, this point center can be represented as A plus B by 2, that is sum of the values divided by 2, it will give you the center. So in this case, if we are going to find out the value of signal, then where it is centered, then what is the value of its amplitude and what is the value of its total width, then we can represent the signal in this representation. So in case of signal x1 of t, if we see for individually for signal x1, x2 and x3 of t, then for the first signal, as the total width is 0 to 8, that is 8 seconds, so the center is going to be 8 plus 0 divided by 2, that is this rectangle is going to be centered at 4. So the center will be 0 plus 8 divided by 2, that is equals to 4. Amplitude of A, you can see here, amplitude is given to be 4 and the total width is from 0 to 8 seconds, that is 8. So for first rectangle we have obtained. Similarly for second rectangle, it is existing in between 4 and 8. It means the midpoint of these values will be 8 plus 4, that is 12, and 12 divided by 2, that will be 6. So it is 8 plus 4 by 2, that is equals to 6. So the center will be at 6 and the total width you can see here from 4 to 8 seconds it is existing. Therefore the tau value for rectangle 2 is 4 and amplitude, the difference, that is 10 minus 4. So the amplitude of this signal is going to be 6. And for this for signal x3 of t, total width is in between 6 to 8, that is tau value is 2. Height of this rectangle is 15 minus 10, that is 5. And the center, if it is lying in between 6 and 8, then the center will be midpoint of these two, that is 6 plus 8 divided by 2, that is 14 by 2, that is equals to 7. So you have obtained all the values, so you can just represent x of t as x of t is equals to, see, x1 of t, x2 of t and x3 of t, all are going to follow this representation. So for x1 of t, the representation is A, that is 4, rectangle of t minus center, that is t minus center is 4, divided by tau, that is total width, 8. So it is your signal x1 of t plus you have to write x2 of t, for which amplitude is 6. So you are writing a rectangle of t minus center, center is at 6 divided by total width, that is 4. And for third rectangle x3 of t you can write a value, that is 5, a rectangle of t minus center, center is at 7 divided by total width, that is 2. So it is the representation which is correct for this signal x of t. But now we are going to see the another representation which will be taken if we are considering the horizontal rectangles, that non-overlapping functions x1t, x2t and x3t. Similarly, if you see the values of that we have calculated for first method, if you will see again signal, center, value of a and value of tau. So for signal x1 of t, see here x1t, x2t and x3t, 3 signals again we are having. For signal x1 of t, in this case this first rectangle is lying in between 0 and 4 seconds. So the center will be at 2 simply by symmetry, or you can take 0 plus 4 by 2, that will give you 2. So first rectangle is centered at 2 having amplitude 4 and total width, that is 0 to 4 seconds, that is going to be 4. Again for x2 of t, for this rectangle it is existing in between 4 and 6, so the center will be at 5. So the center will be at 4 plus 6, that is 10 divided by 2, that is equals to 5, and amplitude is total this amplitude. Now in this case amplitude is now this value, that is this rectangle is having in between 4 and 6, the total amplitude it is having is 10. So the amplitude value for rectangle 2 is 10 and the total width is existing from 4 to 6, so the total width is 2 seconds. Again for third rectangle, if we see for this x3 of t, it is lying in between 6 and 8, so the center will be at 7, that is obtained by 6 plus 8 divided by 2, center is at 7, total width is 6 to 8, that is 2 seconds, and the amplitude at which the value of function is constant in between this duration 6 and 8, the amplitude is going to be 15. So these are the values of a, center and tau if we are going to consider non-overlapping functions. So now again we can represent this signal to be x of t is equals to, for x1 of t we are writing a, that is 4, rectangle of t minus center, center is going to be at 2 divided by total width, which is equals to 4. For x2 of t we can write a, that is what, 10, rectangle of t minus center, center is going to be at 5 divided by total width tau, that is equals to 2, and the third signal is equals to a, that is 15, rectangle of, you can say t minus center, center is at 7 divided by tau and the value of tau is 2. So it will be t minus 7 divided by 2. So we have taken the 3 rectangles in 2 cases. If we have considered horizontal rectangles and vertical rectangles, these 2 values both are correct representation of signal x of t, and using any of the representation, if you have to find out the value of any signal, signal at any particular point, say if you say that if you want to find the value of x of t at t is equals to 2 seconds, then the value will be what? You are going to substitute value of t to be 2 seconds in all these expressions. So if you see here, this will be 4 rectangle of, if you are going to take t is equals to 0, so it will be what? 0. Again 10 rectangle of what? T minus 5. If you are taking t is equals to 2 seconds, then it will be minus 3 by 2, that is minus 1.5, and the third value is going to be 15 rectangle of 2 minus 7, that is minus 5 by 2. Now you have to consider, as you have written, say you have any step function, what you have to consider here, if you are taking a step function, let it is u of t, then what is the value of u of 5? You have defined u of t function to be equals to 1 if t is greater than 0 and 0 for t is less than 0. So whatever value of t you are taking in between in the bracket, if it is greater than 0, then the value of u of t is going to be what? 1. If you have taken u of minus 2, then the value is going to be what? 0. Similarly, if you have plotted the rectangular function, it is your rectangle of t, it is your function rectangle of t. So you can see here that this rectangle of t will be having value equals to 1 if what? If the value of t, that is if t is either, we can say t is greater than minus tau by 2, that is minus 0.5. If t is in between minus 0.5 and plus 0.5, then only the value of this rectangular function is going to be 1. Otherwise, the rectangular function will have value 0. And if it is written that it is 10 rectangle of t, it means the value will be 10 if this value of t is in between minus 0.5 and plus 0.5. So what you have to know that if it is written a rectangle of any value, if rectangle of any constant value, then if this, let us say it is written to be x, then if x lies in between minus 0.5 and plus 0.5, then the value is going to be a. If it is written to be a rectangle of x, then the value will be a in between the duration of x from minus 0.5 to plus 0.5. So now we are going to apply this concept and to check the value what we are obtaining is correct or not. So if you see here, rectangle, if the value in between the bracket of rectangle is going to be in between minus 0.5 and plus 0.5, then this value will be 1. So if you can see here, if you see here, this value is lying in between minus 0.5 and plus 0.5. So the value of 4 rectangle of 0 will be 1. 1 into 4, that is 4. Again if you see here, it is what? Minus 1.5, which is outside the interval. Therefore, this value will be 0. So 10 into 0 will give you 0. Plus this rectangle, again it is having value negative, less than minus 0.5. So this value is again going to be 0. So it will be 0 and you are obtaining the value as 4. It means if you see the plot that is given to you, then that plot must have value of x of t equals to 4 at t is equals to 2 seconds. If you see here, it is the value t is equals to 2 seconds. So what is the value of the signal? It is equals to what? 4 that you have obtained. Similarly, if you follow this relation to identify the value of x of 2. So you can see the value of x of 2 here. If you are following this relation, then it will be, if you are going to put t is equals to 2. So this rectangle, it will be 4 rectangle of 2 minus 4, that is, it is 2 minus 4, that is minus 2, minus 2 divided by 8, that is minus 1 by 4. It is minus 1 by 4, that is minus 0.25. Similarly, this rectangle will have value 6 rectangle of 2 minus 6, that is 2 minus 6 is minus 4 and minus 4 upon 4, that will give you minus 1, and this will be 5 rectangle of 2 minus 7, that is minus 5 by 2, that is minus 2.5. Again you can see that only this value is lying in the range minus 0.5 to plus 0.5. So this value will be 1, but rectangle of minus 1, as it is lying before minus 0.5, so this will be 0, this value rectangle of minus 1 will be 0, rectangle of minus 2.5 will be 0. So again you are obtaining 1 into 4, that is equals to what? 4, that you have obtained using the previous relation. So both the representations are correct, you can go with either one, but what we have seen here, that we will be preferring this method, that is taking x1, x2 and x3 to be non-overlapping signals, because due to overlapping some more complexity will be adding to the problem. So we have seen the representation, that is a rectangle of t minus center upon tau, that how we can use this representation to plot a rectangular function, and we have seen that how this only representation can be used to identify the expression for the given plot. So now we are going to take some more examples, 1 or 2 examples on this rectangular function, and then we will be starting our next signal, that is triangular function. So we have seen that to find value of any signal x of t at any particular value of t, we can use the expression for that signal, that is we can use the definition of that signal. Similarly, like if we have to find out the value of, say, your any discrete time signal x of n is given as u of minus n plus 4, then if you want to plot it, then you know that this signal will be starting from minus infinity and will be existing up to t n equals to 4. It is going to start from, that is this signal is going to be 1 from minus infinity to the value of n, that will be equals to up to 4, the signal is going to be 1. So if you want to verify this value, if you have to find out the value of x of n at n equals to 3, then if you put n equals to 3 here, then what you are going to get is minus 3 plus 4, that will be equals to what? U of plus 1, and you know that by the definition of u of n is going to be 1 if n is greater than or equals to 0, and it is 0 if n is less than 0. So whatever you have obtained in the bracket term of u, it is greater than 0, therefore this value is going to be 1. It is obvious, as we have already discussed, that the signal is going to have value 1 during this interval, and if you put value of n other than or greater than 4, then if you want to find out the value of x of 5, then what is going to be the value? It will be u of minus 5 plus 1, that is equals to what? U of minus, it is plus 4, that is it is going to be u of minus 1, so it will be 0. So if you have definition of any function, and if you want to find out the value of that function at any particular value of t, then you just can use that definition, and accordingly you will be getting the answer. So as we have seen that any gate function will work as a limit changer, and rectangular function is nothing but a gate function, therefore this rectangular function is again going to be work as a limit changer. It means if we have, say we are trying to understand this concept by an example, if you have given a signal, if you have to find out the area of signal x of t, that is equals to say 2 cos of pi t into rectangle of, if we write minus 4t plus 2 divided by 8. If you see, if we are taking a rectangle which is minus 4t plus 2 by 8, then you know that this rectangle will be existing in between two finite limits, and it is a periodic signal 2 cos of pi t. If only 2 cos of pi t is written, then you know that the graph of cos t exists from minus infinity to plus infinity. We will be discussing these functions in more detail when we will be explaining our topic, that is periodicity and period. But for the time being, if you see, if it is any function and if you are multiplying this function with a rectangular function, then we have seen that now this function is going to exist only between these intervals in which this function is non-zero, because this function will be existing, then it will be having value 1, and after the existence it will be having value 0, which is multiplied with any function to give the resultant value to be 0. So if you want to find out that in which duration this rectangular function is existing, then you already know that if it is written to be rectangle of, then we can first take this minus sign common and discard it, and if we want, then we can take overall coefficient of t common, that is if we can take minus 4 common, then we can write it t minus 0.5 divided by it is 8. So what you can do, you can just eliminate this sign of time reversal, and this signal will equals to, and this 4 will get cancelled with this 8 and will give you 2. So this function will be equal to rectangle of t minus 0.5 divided by 2. Now you have obtained the representation, that is a rectangle of t minus center upon 2. It means you are going to multiply, see it is your cos function. If you are going to draw a cos function, it is your cos pi t, a signal, it is cos of pi of t, it is cos pi t, and we are going to multiply this signal with a rectangular function. Which rectangular function is existing? I have not you can say I am not plotted the signal according to the period of this function. I am just representing that we are going to multiply this cos pi t, or 2 cos pi t, actually it is given to be 2 cos pi t. We are going to multiply this signal with a rectangle. If you compare this with the standard representation, a rectangle of t minus center upon tau, means this rectangle is centered at 0.5, say it is the point 0.5. So it is centered at 0.5, and from 0.5 total width is 2, means on both the sides the width will be 1. So if we move left hand side by 1 unit, then you will be at this point, that is minus 0.5, and if you have to take total width 2, it means this function will be existing 1 in the right hand side also from this point 0.5. So this point will be 1.5, and the value of this rectangle is going to be 1. It is your function rectangle of t minus 0.5 divided by 2. So if you have to multiply these two functions, then you know that now you are going to get the function, that is plot of this function only, but only in the duration from minus 0.5 to plus 0.5. So you can say that this function is having value 1, so anything multiply with 1 will give you the same value. So you can say that now x of t is equals to 2 cos pi t, but only in the interval when t is greater than minus 0.5 and less than 1.5. It means this function will be having this value, but only in between this interval, and after that it will be 0. It is 0 otherwise. So if we want to find the area of the signal, then we know that area of signal x of t is what? Integration from minus infinity to infinity x of t dt. But now as this x of t signal is existing only in between minus 0.5 to 1.5, so we have changed the limits of integration, and in between these limits x of t is going to be 2 cos pi t, and we have to integrate with respect to t. Now if you see here the result of integration, then area of x of t is equals to 2 can be taken outside of this integral. For cos pi t with respect to t, integration will be sin pi t upon pi, that pi can also be taken outside, and we have to put values of limits from minus 0.5 to plus 1.5. This 1.5 can be written as 3 by 2, it can be written as minus 1 by 2. So what we have to take is, it is equals to 2 upon pi times, if we take sin 3 pi by 2 upper limit, then it will be sin 3 pi by 2 minus, if we take minus 0.5, then it will be sin minus pi by 2, and you know that sin minus theta is minus sin theta, so it can be, this sign can be made plus, and you can write sin plus pi by 2. So if you have now to add up these two values, that is sin 3 pi by 2 and sin pi by 2. Now by the symmetry of sign you can just find out the values. It is the graph of sign at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, at odd integer multiples of pi by 2, the sign is going to have values plus and minus 1, and at even integer multiples of pi by 2, or you can say integer multiples of pi, the sign value is going to be 0. So it is plus 1 pi by 2, it is 2 pi by 2, it is 3 pi by 2. So at 3 pi by 2, the value of sign is going to be minus 1. So this value is minus 1, and sin pi by 2 is 1. So minus 1 plus 1, what is the value? It is 0. So the area under this function x of t is what? 0. So now if you are thinking that how it is possible that the area of this function is 0, so you know that in any periodic signal, as you know that this cos function is periodic. So in cos or sine, whichever function, if it is periodic having symmetricity about the y-axis, that is if it is having both positive and negative equal values, then if you are going to integrate, it means you are going to find out the area. So in one time period, it is one time period of this function, in one time period this positive area, total positive area is going to be equal to the total negative area. So if you are integrating for integer multiples of time period, then the cos or sine function will give you the total area equals to 0. So in this interval, if you are getting total area equals to 0, it means that what you can conclude by this result, that you have integrated the cos function for integer multiple times of its time period. If you see here, we have not discussed, still you know that if there is a representation that is a cos 2 pi t, then it can be compared with a cos omega naught t. Means if you are writing only the function 2 cos pi t, then for this function frequency omega naught is equals to pi. And if you want to find the time period, then t is equals to 2 pi upon omega naught, that is equals to 2 pi upon pi, that is equals to what? 2 seconds. It means time period for this cos function was 2 seconds, and the interval in which you have integrated, you can see here, you have integrated from minus 0.5 to 1.5, means total interval is what? 2 seconds. It means you are integrating the cos function over one time period, therefore you have obtained the area to be 0. If you want to take other example, say we have signal x of t which is given same as 2 cos pi t, but now if we have to multiply this with a rectangle, that is rectangle of what we have taken earlier, it was 4t plus 2. So if we take say 4t minus 3 by 8, or we can say upon 2. So if you see now this rectangle, then this rectangle for the comparison with the standard representation, you can write this rectangle, that is rectangle of 4t minus 3, it can be written as, if you take 4 common, then it can be written as t minus 3 by 4 divided by 2, which can be written also as, it can now be simplified to be as rectangle of t minus 3 by 4 divided by 1 by 2. If you are getting 2 in the numerator, then you can write it as 1 by 2 in the denominator. Now you can compare this representation with a rectangle of t minus center upon tau. Means the center value, it is the center of the rectangle and it is the total width. It means now this rectangle is centered. Now if we are going to plot this rectangle, then this rectangle is going to be centered at 3.4, that 3 by 4, that is 0.75, and we have to take a total width of 0.5. It means now 0.25 width will be on each side. It means this point will be 0.5 and this point will be 0.75 plus 0.5, that is 1, and this amplitude is 1. This is your signal rectangle of t minus 3 by 4 divided by 1 by 2. We are just taking easy examples. You just don't have to get confused that why we are discussing this. We are discussing because we just have to implement these concepts in our further lectures. Either it is Fourier transform, or we have to calculate energy, or we have to calculate power. So we just have to understand that how we are going to plot the given signal. So if this rectangular function you can plot, then you can see now that the total width of rectangle is what? 0.5 to 1. The total width tau is going to be 0.5. Now again you are multiplying this rectangle to a periodic signal which is having the same frequency. For this signal cos 2 cos pi t, the signal is again having omega naught frequency value, that is 2. So the time, it is omega naught frequency is pi, so the time period t is equals to 2 seconds. But now you will have to integrate this signal, because you know that now this product will be existing only between these two intervals, that is from 0.5 seconds to 1 second. Now as you will not be integrating this signal for a complete time period duration, because now you have to only integrate it for a duration of 5.5 seconds and the period is 2. So we are now not integrating this function for overall time period, therefore now the result of area will not be 0. Now if you find the area of x of t now will be, now you will take the integration value from 0.5 to 1, function will be the same, that is 2 cos pi t, because in that duration the value of this function has become 1, therefore x of t is this into 1, that is equals to the same value 2 cos pi t, and now we are again integrating this, then we are again getting the value, that is 2 upon pi into sin pi t, and now we have to put values of t from 0.5 to 1. So it will be 2 upon pi, and if we put t is equals to 1, then it will be sin pi, that is going to be 0, minus sin t is 0.5, so it can be written as pi by 2. So now what you are getting is sin pi, that is 0, minus this value 1, that is minus 1, so you are getting minus 2 upon pi. So now the area is non-zero, and if the area is negative, it means now if you will be integrating cos pi t function, then the area that will be enclosed in between 0.5 and 1 seconds will have more value below the y-axis, below the time axis, that if you are going to plot, see, you can see from here also, if it is the graph of 2 cos pi t, and if you have said that the total time period is 2 seconds, it means this value is 2 seconds, it means this value is 0.5 seconds, this value is 1 second, this value is 1.5 seconds. So if you see here, you are going to integrate this function between these two limits, 0.5 and 1. So in between 0.5 seconds and 1 second, the plot is having the values that are all negative. Therefore you have obtained this negative area, and this negative area you have obtained to be as minus 2 upon pi. So what we have seen here, that a rectangular function or a gate function can be used as a limit changer. That means it confines the value of the signal during a particular interval in which that rectangular function is existing, and therefore the overall function that may or may not be periodic, may or may not be causal, but that function will be adjusted in the values of time according to the given rectangular function. So it is about rectangular function. We will be discussing more about rectangular function when we will be discussing energy signals, and then we will be taking the energy of rectangular function. We have, for the time being, we have seen that area of rectangle is a tau, we will be seeing energy will be a square tau, but now we are going to start our new signal, that is triangular function.